seminar. And I'm very pleased to welcome Vass, who's going to give us a talk today on the Smart Hospital Living Lab.
Thank you. Hi guys. Oh, I know it's getting late. I also just had lunch. But Cecilia made me walk all the way from Jesus coming. So I'm actually quite awake at the moment. All right. So today I want to talk to you about some unfinished work. Actually, we've published very little. So I'm really looking forward to your feedback and criticism because it can genuinely affect the direction of our work. So please feel free to comment and advise or criticize. Before I start, I just want to say that the work I'll be presenting has been supported by a large number of people at the University of Melbourne and also at my previous institution at the University of Oulu in Finland. And so they're the guys and ladies who make the magic happen. So I just want to start by asking you, just raise your hand if you know what's a living lab. All right, it's more people than in Finland usually. So kind of a living lab is a concept that started in the European Union. And the best example I can give is like Jurassic Park, where you had those crazy scientists in that remote island working with dinosaurs and developing technology to kind of clone and create dinosaurs, and the dinosaurs were there, and they were there, and they were all in the same place. So the notion of the living lab is to create this kind of environment where the people who are doing the research are kind of in the same place with the people who will be affected by the research, and they're all in the same place that's hosting the outcome of the work. And yes, the kind of Jurassic Park Island maybe was a movie, but actually these kinds of environments do exist. So for example, you get this in the Antarctic. And if you look at the European Union kind of website, there's hundreds of living labs across the world. So why did I decide that we should try and do a research in the context of a living lab? Why not just a research lab? And the reason is that kind of I was really motivated to find a good practical way to go from ideas to practical application quickly. But I realized that to do that is really hard if you're just stuck in the research lab. You need to find other people to work with you to make this transition quick and easy and actually doable. And so in a living lab, you have this kind of constant cycle of innovation. So when you're doing your research, you're kind of co-creating with your end users, or in the case of Jurassic Park with dinosaurs, I guess. You would explore what you're trying to do with stakeholders. So it's not just you reading literature, but you're actually talking to people and saying, do you think I'm on track? Do you think this is an important problem to solve? You would then have the ability to quickly and easily deploy prototypes, and then through that deployment, do some evaluation, collect evidence, and then go back and repeat this process over and over again. And hopefully, that's how you get the magic to go from an idea to a practical application, solving an interesting problem. So in our living lab, we have the University of Melbourne. We have kind of a computer science department where I'm based, but we also have partners in population health, so kind of medical and health researchers. We're working with a number of hospitals that are both next door to us, but also kind of a bit further outside the city. We now have 4 hospitals, and 3 hospitals. And also we're kind of constantly talking to the local government, and in particular this Department of Health and Human Services, think of it like a ministry basically, who are giving us feedback on this is where we think the money and the research effort should be invested. And before I kind of start showing you the projects that we're working on, I just want to give you a quick background regarding the kind of work that we do. So where's our kind of our expertise? And I would say it lies somewhere between ubiquitous computing and user-centered design. So we can build technology, we can program, we can develop, but also we do this user-centered development process where we could interview people and kind of try to um, formulate the requirements for the technology before we create the technology. So we're kind of very comfortable building all kinds of interactive systems, both software and hardware. We're comfortable with sensors and actuators. We can kind of create interactive prototypes. We use a lot of machine learning, and we kind of do a lot of modeling and analytics. And we have a lot of experience with real-world developments and deployments. And there's a kind of a whole lot to say about all the things that can go wrong in a real-world deployment. Okay, so that was the introduction. I believe most of my slides from now on are just pictures. So the vision for our living lab is to find a way to improve how hospitals operate. And in particular, we're focusing on two kinds of ways to make that improvement. In terms of safety, we want to find ways to reduce the errors that happen in the hospital. And in terms of efficiency, help hospitals run better. And when you talk to hospitals, you realize they actually have very little clue about what goes on in the hospital. They will tell you, actually, we don't know where our patients spend their time while they're here. So these two general objectives that have been driving our work. And the 4 projects I'm going to talk about today, I'll just give a brief introduction, some detail. If you want to know more, please let me know, and I'll go in a lot more detail about exactly what we're doing. So I'll talk about 4 projects. Am I moving too much? Okay, good. The first one is a smart pillbox. This is a kind of a prototype we've built that can identify medical pills based on their chemical signature. A second project is tracking patients in and out of operating theaters in the hospital. We're working on a project to detect and measure how well staff wash their hands, disinfect their hands. And finally, I'll talk about this IV monitoring tool. It's a prototype we've built that clamps onto IV lines and monitors what's running through them. All right, so very, very quickly, the smart pillbox. A big problem in hospitals is that they give the wrong pills to the wrong people. And to me, that sounded absurd. Like, why would that happen? How careless can you be? But actually, there's many reasons why this happens. Part of it is because pills get stored outside their boxes because their boxes take up a lot of space. So it's kind of very often the case that you'll see just containers with pills that are unidentified, or maybe they have one label on the outside of the box. Situations happen where a patient needs to take 8 or 10 pills at the same time, and so the nurse might just pick the wrong pill because they all look alike, right? So this is kind of a typical assortment of pills. It can be very easy to confuse which pills, which is which. And I can say that because we actually did give these pills to nurses and asked them to tell us which one's which. Yes, they were confused. If there is no label, it's really hard to tell what's a pill. So we built a box. It looks like this. Inside there is some technology I'll talk about in a bit. But basically there is a kind of a window on top of which you place your pill, the sample. This technology works with near-infrared light, so it's called near-infrared spectroscopy. What it will do is it will emit infrared light. The range is a few centimeters, that's why it's called near-infrared. The sample will absorb and reflect this light, and what gets reflected depends on the chemical composition of whatever is being scanned. And it turns out that pills are a great object to scan using this technology because they're manufactured very precisely. That means there's very little noise. And what you'll get when you scan a pill is something that looks like this. These are the different wavelengths. And basically you get a spectrum. There's literature that tells you what kind of filtering you might want to do on this data. But basically, once you have the spectrum, this just turns into a classification problem, right? So we use these as a signature. We train a big database with all the pills, and then we just do matching. And we see, okay, this seems to be vitamin C pill. This is just a visualization from PCA. So basically, pills, as I said, they're manufactured in a way that makes this very, very convenient. Unless they look like this, semi-translucent, in which case it's really problematic. To try and resolve this issue with reflectance, we've tried a number of things. One is to add these flaps here to reduce the amount of light bouncing off. And we've also tried with a little black box to completely cover the sample. So here we have a picture. We did this demo for the minister who visited our lab. So Yiton here, he spent a year walking around campus with lots of pills in his backpack because of his project, right? Where's the prototype? So the prototype is here. You can see that little black box. And basically, guys, it works. It works quite well with pills. You can definitely say what pill you've put there. We've worked on ways to make this quicker. So if there's a nurse that needs to take 10 pills, you can do it in a matter of seconds. And the system can confirm that, yes, you're giving the right pill to the patient. So this can be a pill that you picked out of a box. Maybe it had the wrong label. There's all kinds of reasons that lead you to give the wrong pill. It can be mislabeling at the manufacturing plant, at the storage. There's a number of reasons. What you also see in this picture is our ad hoc IV line setup. So actually what you can't see up there, we had the coat hanger hanging from the ceiling, and then we wrapped this IV line here. This IV line is going down through a prototype that basically does the same thing but with liquid. So a problem in the operating rooms is that during an operation you might need to have multiple kind of medicines being delivered to a patient simultaneously, and sometimes mistakes happen. You put the wrong, you attach a wrong bag of medicine, or you put the wrong thing in the tube. And it's something that's really hard to kind of validate with the eyes, because, you know, through this tube, everything looks kind of transparent, translucent, or some kind of color. It's really hard to verify manually. So what we've built is this little clamp. It's mobile, it has a screen. It's a clunky prototype, but you attach it to the clamp, and it starts doing this scanning continuously, and it's telling you what it thinks is going through the tube right now. And, you know, you could cross-reference this with allergies that a patient might have, or against a kind of a medication schedule, et cetera, et cetera. So it's a way to alert you to potential mistakes. So yeah, that's a clamp. It turns out there are all kinds of different tubes. So we had to 3D print the casing, and we made this kind of interchangeable tube holding, so we could fit all kinds of tubes. This is where we did our initial experiments in the lab with a kind of a sample holder, very precisely dropping different medicine. Initially, we wanted to try this with cancer medication, but it's just much easier to do it with soft drinks because you can buy them at the supermarkets. So one of the things we learned is that actually, unlike pills, what matters with this kind of IV medicine is the concentration of the active ingredient. So not so much the type, but also the concentration. And there's all kinds of formulas to figure out what's a safe concentration, depending on, I think one that's used has to do with the square meter surface area of your body. That kind of tells you what's a safe amount of concentration. But what we did here is try to measure the concentration of sugar on these drinks. And it turns out it works really well. One thing I'm going to show you in a bit. Let me go back. Initially, we thought there would be one single frequency that would help us estimate the concentration of sugar. but that doesn't work so well. You need to use multiple frequencies basically in your model, and then you get kind of really good results. This is the equipment that we use inside the box. We just buy it. It costs about $1,000 at the moment. It's quite small. Here is kind of the schematics of the little clamp we've built. There's a Raspberry Pi driving everything, so everything happens locally, the processing. This is, I think here we were using iced tea to measure sugar concentration. That's what it looks like up close. We built a very basic user interface to drive the scanning process. And yeah, so these are the graphs that show you that if you rely on a single frequency, the results are quite poor. The reason why I raise this is because there are prototypes that do exactly the same thing, but they only have one frequency that they can measure. They can be much smaller, much more mobile, but they only have one frequency. Whereas what we're using has a spectrum. This gives you much more data. All right. By the way, I guess feel free to ask questions or yes.
So if you go back to that one, is this the concentration of a particular compound that you're looking at?
So we did that for sugar,
Right.
and we can also do classification of the soft drink quite well. If you want to, so I think it's going to be very possible to do it with medication. So the way it happens with IV lines is you have like 3 or 4 what are called volume expanders. So you know those bags of liquid, that's a volume expander. And in that you drop a small amount of an ingredient. So you have a kind of a combination of a volume expander and an ingredient, and you need to account for both in your model. But it seems like it's very doable.
Okay, and how much specificity do you get picking out different ingredients?
So you mean that like the classification rate?
Yeah.
It's about 99%.
But so you can only look for sugar, or you can look for multiple things?
So these are 2 separate things. So one is that you look at a liquid and you say how much sugar is there. The other one is you look at a liquid and you say, is this a Coke or an iced tea? Right? So the latter one works really well. The former one, so let me go back to this graph. So that's the kind of result. So here is the ground truth, and here is the prediction. It's kind of, it works reasonably well. There's a big problem when you come down here to very, very small concentration levels. That can be tricky to pick up. Yeah.
If you wanted to do something other than sugar, then if you wanted to do, I don't know, the amount of a cancer drug or something,
yes,
concentration, how well do you think it's going to work in that setting? Or is that unknown because it depends on how the infrared spectrum?
At the moment, it's unknown. I think it will work very well. And what we've actually developed, if I go back, we've developed, so there's a kind of a very specific protocol that food sciences work to do this kind of work, and we've adapted it for our purpose. So you need to take multiple samples from independent samples and so on. So there is a process to collect training data basically. And we would just follow the same process, but instead of sugar, we would put something else in the mixture. Yeah. Okay, the next little project that we've been working on has to do with indoor localization. And I realize that there's a lot of history of that here, so I'll be very clear, we're not making a contribution to indoor localization, but I want to show you how we're using it in this context. All right. So the hospital said they have about 8 operating theaters. And they said every hour that this theater is not being used, there's no operation taking place, costs us a lot of money. It's a fixed cost. So what they're trying to do is maximize the amount of time that the operating theater operates, right? And they actually have, I should have shown the picture, they have a poster where the doctors get ready, the surgeons, it says, you know, it costs us $10,000 for every hour that we don't do anything in the operating. They have this poster. So they're really trying to maximize their use of the operating theaters. So we said, hey, we think we can help with this because, you know, if we start kind of collecting data about the different stages of where the patient is leading up to surgery and after surgery, and also understanding where the anesthetist, the surgeon, all the nurses, you know, did they come late to the operating theater because they had another surgery or they arrived late to the hospital and so on. We can try to build a model and help you understand where is the bottleneck, how to improve the occupancy of the operating theater. So as I said, we're not making a contribution to indoor localization, but I just want to show you the technology we're using. Basically, the way we decided to do it, because quite often our participants are unconscious, right? They're being operated. We said, let's not use mobile phones. What we'll do is we will give everyone a Bluetooth beacon like this. These cost about $10. They're made by Radius Networks from the US. And then we will install a bunch of these gray boxes in different rooms in the hospital. And what we're going to do is room level localization. Inside that box, don't tell people at the hospital, but we put smartphones. We could have done this with Raspberry Pi or some other kind of technology. I think this was just the easiest way to do it for us. So what we're interested in doing is understanding how people move between different rooms in the hospital. What's interesting is that a hospital is what architects would call a strongly typed space, which means a space has a very specific purpose. Schools are another example of strongly typed places, police stations and so on. Perhaps kind of a public square might not be very strongly typed. But nevertheless, if you know where someone is, you can tell a lot about what's happening or what they're supposed to be doing. So this is us preparing the gray boxes. The one thing we wanted to make sure is that we know, so we gave these tags, you can see they're numbered, both to patients and staff. And a big problem for us, kind of time consuming, was to create these IDs and print them there. Because when you have thousands of these tags, what you need to do is turn all of them off, pick one, turn it on, see what's the kind of the minor, the Bluetooth minor, and set it to a specific number, and then print a tag with that number on it. What that allows us to do is that a nurse can give this tag to a patient and just write down on a piece of paper, I gave tag 343 to this patient. And that's the information we need to then link all our data to all the hospital data and the medical records for each patient. Yeah, I set up basically a PhD student sweatshop for a couple of days, and we had a line of printing and turning things on and off. It's time consuming. This is us in the hospital. This is the recovery area. We're trying to understand how things work. Where should we place the equipment, and make sure we capture the data that we need to reconstruct people's journeys in the hospital. This again, the recovery area, mandatory selfie in the operating theater. Mom, I finally made it. I'm a doctor, okay. Again, this is a kind of one of the places where we put those gray boxes, and here's a close-up. The reason I'm showing this is because it looks really messy. It's extremely messy. Lots of people interact with all this technology here. And the biggest problem we had, can you guess what do you think the problem we had here was? Yes. They kept unplugging our equipment. And it's really hard to tell them, why did you unplug it? They're saying, well, someone was dying and we had to plug it. It's really hard. But they were really kind of understanding, and they said, okay, why don't you put some labels here? But it's still a problem. It's still a problem when people unplug it. And here's where the smartphone has kind of helped a bit, because it has a battery, it can last for a few hours without power. And what we also did is we made this dashboard so we can be alerted when something goes offline. We also have an alert for the light sensor in case someone has opened the box, in case they're trying to figure out what's inside the box. And this mixed approach has sort of helped us maintain a kind of quality of data we're collecting. This is what the data looks like. This is data for one of those tags, right? And what you see over here is the different rooms, different areas in the hospital. It's a very dense environment, so as you'll see, there's kind of a lot of overlap. At any given time, a tag is detected by multiple gray boxes, right? I see a lot of people nodding. Good. But I think we discovered that through a combination of single strength and number of packets arrived, actually we can do quite a bit of filtering. And what I'm showing here in the gray line is the ground truth. So we did some kind of movement through the hospital. So we recorded the ground truth. And the blue line is what our filtering tells us. So it seems to work reasonably well. We can reconstruct where people go. So up to this point, there's really no research contribution. There's small pieces here and there. I think where the contribution comes is here. So by capturing longitudinally the movement of people across spaces, we can actually create this kind of model where we tell the hospital, hey, once a patient arrives in the reception, this is what happens to them, this is how much time they spend going to different rooms and so on. And then we can map this against the business processes of the hospital, right? The hospital says this is how a hip surgery should happen. This is what we expect. And then we can go back to them and say, actually, well, this is what's really happening. Here's where the delays are according to your business process and so on. So I think this kind of model, I'm kind of very excited about this, because the way we build these gray boxes is you can just pick them up and deploy them in a different space, in some other environment, and it would sort of give you the same data. And then all you need to do is map it to the business process of the place. Yes?
Are you doing any fingerprinting training, or is it just whichever one they seem closest to at the time?
Sorry, can you, prediction?
For telling which room you're in, are you taking the closest beacon by signal strength, or are you doing fingerprinting?
Yes, so we're not doing any advanced fingerprinting, because we position those gray boxes in such a way so that if you're close to them and there's no wall between you, you're probably in that room. So again, our desire is to do room level localization, so we're not too fast. I think from our kind of pilot test, it works reasonably well. Yes?
So you talked about some of the difficulties with power. Do you also have a compliance issue in terms of staff and patients wearing their tags?
Totally. So I can talk about that for ages. And what's strange, actually, I have a point about this in the last slide, but we're working with the management of the hospital on what they call a performance improvement project. And they're totally on board with it. And then we go to the actual wing, and people are like, well, what are you doing? I'm not so sure. Have a different manager here. So we had to organize like little seminars to explain what we're doing, that we're not spying on you. We had to work with the surgeons to agree on how they would carry the tags. We found a reasonable way to do it. How the patients would carry the tags, who would give the tags, who would collect the tags when patients leave. There's all these kind of logistics you need to sort out. Yeah. Yes.
Yeah, sorry. I had a bunch of questions, but I'm really interested in the socio-technical aspect. So clearly, hospital is a very strong power space. especially if you're essentially mapping it to business models and potentially uncovering to management what the surgeons have long established as their working relationships without the management knowing. Do you think that's part of the compliance issues, or do these graphs map nicely to what you would get if you asked the surgeons of what you mentioned?
I think these are probably reasons why there is some kind of concern. And it's not only surgeons, also nurses, so kind of across the level of seniority, people are skeptical. There are some people who are very positive, but I think they're skeptical, not unreasonably skeptical. I think once you explain what you're doing, you show them these high-level visualizations, they're like, okay, you're not really spying on me. But definitely, they're concerned about. So the way we kind of argued for was that, look, if your life sucks because the schedule is bad, let us do this and we'll figure out a better schedule for you. We want to make things better. So we don't want you to overstretch. That you're running from one end to the other and so on. So I think, yeah, it's a very complicated issue, definitely.
Does that fit with the story you told to managers?
Yeah, so the managers just want to understand what's going on. They want some evidence based on which they will create new policies, new scheduling. Yeah.
Well, in Australia, it's interesting because the enterprise agreement generally make it illegal for you to track employees for performance reasons. So we looked at doing that in a logistics company, and legally you couldn't because,
no one has raised that.
Maybe the hospitals are different.
And we also did the ethics in the hospital, so that never came out.
Then we're working on a hospital, and the issues we're looking at is similar to what Peter was saying, looking at the impact. I'm particularly interested in the psychological impact that surveillance technologies have on employees. We're working with a large group of nurses. I was wondering what your thoughts are about that.
So our thoughts are definitely, we've done some interviews, we'll do more. So we really want to understand what kind of opinion or relationship the staff develops with this technology, but also the patients. So actually what I found very interesting and surprising was that in talking to the staff members, they do seem to mention the well-being of the patients a lot. And I found that quite surprising that even they would kind of prioritize them over their own well-being. They would kind of, I was just not expecting that, but that's what I observed.
How are you servicing this data? So who is your end user? Are you providing a real-time stream of this kind of thing to hospital management? Are you producing sort of a analytics dashboard to them? Are you just producing like aggregate reports for certain things that they ask you about? How are you?
I think all those are possible. At the moment, we're doing real-time monitoring to ensure nothing goes offline. And then we're starting to produce static reports. And we also have a dashboard where it's kind of an interactive, shiny dashboard where you can go and look at segments of the data. And we're using this internally to validate our algorithms for filtering and so on and so forth. Potentially, we could build a dashboard for the so the people looking at this are the management only. But for now, we just want to create kind of graphs like this with some broad statistics and maybe break them down by surgery type.
Do you have an idea if management wants that?
Yeah.
If they want this, or do you feel like maybe they'll want more?
I don't think so. I don't think they're interested in. They don't have time to go and play with interfaces. They just want some kind of report. At least the people I'm talking to. Yeah.
I mean, the challenge of that would be that it would be difficult to keep aggregate data because you know who works in which surgery room, and then you're identifying the people. You can't keep people anonymous that may be causing these problems.
Yeah. Any other questions? Okay.
So,
yes.
Tell me, what was the baseline? I mean, I find it incredible that the hospitals today do not have an awareness of these processes. So what was your baseline in this particular case?
When you say baseline, you mean in terms of performance?
No, in terms of these processes that you identify and the dual time the patients
So we're still doing this. I think there's two baselines. One is what the business process should be. The second one is the percentage of the operating theaters, the percent of time that they're offline, that they're empty. And ultimately, what we want to do is success would be if we introduce policies that increase the occupancy rate of the operating theaters.
I
Right?
understand. But at this point, the hospitals do have some level of estimation of this entire time frame, right?
I'm not sure I understand.
With those, you were talking about business plans and
Yes.
like business process and comparing that to
Yes.
that. Is that your baseline then? Essentially, you'd assume that the business process of the hospital would be their assumption of how stuff
Yeah.
happens, right?
Yeah.
You're essentially comparing it to that.
So we want to do it in the order of months, if that makes sense. And actually, it's not necessarily time; it's the number of cases. So they want to see multiple hip replacements and see how that evolves. Right? Yeah.
Sorry, one last question. When you're talking about the occupancy of the rooms,
Yes.
can you have some bad outcomes that kind of fall out? For example, the system will link to the operations being longer just so that the room is not unoccupied? Like, what's the success criteria on that? Or is
Yeah,
that not part of it?
they've given us this criteria, so they said we want to increase the occupancy. Clearly, one way to do that is for operations to take longer, but that means we're doing fewer operations.
Well,
Yeah. So I trust what the management is telling me. They say that as a first step, we want to make sure that it's getting used more.
So one way to increase this is at the end of the surgery, we all want a tea break.
yeah,
Well,
exactly.
I'm
That's what I
hoping
mean.
in the operating theatre for 15 minutes, go and have my cup of tea, come back, and then the stats are happy, everyone's happy, and he's had his tea.
Yeah.
Yeah.
Yeah,
So
let's
it's a
just
question
keep,
about whether they can play with the technology in that way.
let's just
and
keep
Yeah.
it open here, right? And go and have this conversation.
Sure. Yeah. I guess the main reason why occupancy is low is not because there's no one there. It's because not everyone is there. So, for example, the anesthetist and the surgeon might be there, but they're waiting for the patient who is still being prepped. And the patient hasn't been prepped yet because perhaps the nurse prepping the patient had to tend to something else before. So it's not like a black or white. So you need the right mixture of people in the room for the operation to take place. So I think we want to map those kind of complex dependencies and figure out where do bottlenecks have. Do patients arrive late? Do nurses arrive late? Do surgeons? Maybe surgeons have too many operations in the day. I don't know. So we'll see. Yeah. All right. The last project. So what time do we need to end? Okay. All right. There's 15 minutes to go. So the last project is hand wash detection. So many people die in hospitals due to infections, and those infections happen because staff members don't wash their hands properly or don't wash them at all. And so the hospital said, can we do something to improve the situation? Maybe better training. In Australia, hospitals need to demonstrate to the government every year that they have a high enough rate of compliance. Otherwise, you lose your license to operate. So hospitals get accredited. So this is something that they need to do. They need to show to the government that our staff wash their hands. The way they do it now is through manual observation. One of your colleagues will follow you around. And of course, you're going to wash your hands if that's happening, right? And everyone knows that this is unreliable data. The interesting thing is that there are clear guidelines about how to wash your hands provided by the World Health Organization. And that's kind of the standard that you need to follow when you're washing your hands. So initially we said, hey, okay, we'll get some smartwatches, strap them on you, and then kind of do some gesture recognition. And immediately they said that's not going to work because the smartwatch is a source of infection. So really, you want to have your forearms kind of clean, and when you do proper scrubbing, you need to wash all the way up to your forearms if you're preparing for surgery. So then we said, okay, we'll try some of the other technologies. So we're actually playing with Mayas that I think have now been discontinued. But anyway, they seem to work well. For a moment, we thought about leap motion, but there are many reasons why it doesn't work. And we eventually kind of landed, when talking to the people in the hospital, we agreed that we would try and monitor this lotion rubbing compliance. So here kind of a zoom in of the instructions how to rub your hands. This is with lotion, and this is how to wash your hands with water and soap. It's a slightly different process. And actually now the WHO has kind of prepared this joint diagram. So there's kind of a core that's similar. And then, of course, if you're using water and soap, you need to wash off. Otherwise, you just need to let it air. So I guess you can see where this is going, right? It's kind of activity recognition and seeing how well people adhere to this protocol. We started by trying to establish where is the best place to collect data from. So it wasn't clear if the lower forearm or the upper, is this upper forearm or lower upper arm? I don't know. Anyway, these two places, and dominant or non-dominant hand. So we had 4 of these. So this is not what we would do in the hospital, right? We're doing this during the training phase, and we're only doing this to figure out which is the best place to collect data from. And it turns out, so we were worried that up here, which is really where we want to be, we were worried that it wouldn't work well, because maybe there's not many degrees of freedom. But it turns out you don't lose a lot by moving it up there. And it makes a huge difference, because they were also saying, no, over here you can't really, it's going to be a problem. This is kind of how we're collecting our training data. This is one of my PhD students, Chao Fang. He's got super clean hands. He's been spending hours and hours washing his hands. So basically what we're doing is collecting data, labeling them, and then calculating features for each stage. There's a couple of challenges where basically we build a classifier. That can tell in which stage you're in and how much time you spent there. For the core stages of the process, this seems to work reasonably well, so it can differentiate. But it can also, if you do these steps out of order, it will also detect that you've done those steps but out of order. And this is the kind of, we already built a prototype to help visualize how well you're doing with your hand washing. The idea is that here's a record of the hand washing events we've detected, and these are the different steps in the hand washing process and how well you've done each one. We can give you feedback and maybe do some on-the-spot training. We're still trying to finalize this, but again, there's a lot of tension. There's administrators in the hospital that say that people, our staff, need to improve their practices. Then you go to the different wards and they say, no, our people know how to do this very well. There's this tension. So we're trying to present this as perhaps an opportunity for training or education, perhaps of young staff members, just to remind them, or just a quantified self approach, where you would just see your own data, no one else would see it, and you would just reflect on, perhaps you could change your habits slightly when it comes to how you rub your hands. So I've shown you just 4 projects very briefly, and kind of up here I've mapped the various stages of maturity, going from co-creation, exploration, building a prototype, evaluating, publishing, then applying for funding, and then running some proper trials. And I've just mapped here the different projects based on the progress we've made. So for the pillbox, we already got 1 publication at UBComp. There's a second one already written and submitted. we've started applying for funding. We haven't been successful yet, but if we get funding, we would then run a trial in the hospital. And the one thing I want to point out to perhaps the younger researchers in this audience is that you might be surprised that the funding is at the end. Because I used to think, oh, I need to apply for grants, I get money, I do research. Actually, that's not how it always works. And also, you don't need a lot of money to do what I've shown you today. Perhaps the smartphones were a bit expensive. But, so really what you need when you're working in a kind of a health hospital environment and to run trials, they're not going to fund you to develop the technology. They're going to say, you know, you find a way to create the technology, give us some evidence that there is potential for it, and then we'll give you money to run a trial. So that was kind of a culture shock for me. I had to understand that's how things work. And so kind of the same for all the other projects that I talked about today. So in our living lab, kind of hopefully we're trying to achieve this notion of continuous innovation, that we build a prototype and the next day we go take it to the health and safety officer or maybe kind of junior staff members in the hospital, and they give us feedback, right? And say, well, this is not going to work. I don't like it. Stop spying on me, and so on. And the key is being able to do this continuously. I also have some kind of concluding thoughts about this kind of work. Clearly, you know, if we manage to make this work, there's an argument that less people are dying, or hospitals are able to better fulfill their responsibility towards society. But I think an interesting angle to this is that although we're working with 3 hospitals, hopefully the solutions we develop will be generalizable, because hospitals, as I said, are strongly typed. So perhaps if we develop something in one hospital, it would be easy to apply it and use it in a separate hospital. This is a way to get funding. So actually, how you get the big bucks, you do lots of these small projects, you bring partners together, you show that you have potential, and then you apply for these big multi-million-dollar grants, hopefully, to run trials. I've also found that from the moment one of the things you need to do, again, talking to younger researchers, one of the things you need to do is kind of focus your work. They keep saying, focus your work. And I kept thinking, if I focus my work, I'm going to limit myself, right? I'm going to give up on a number of opportunities. But actually, as it turns out, that when you focus your work, more opportunities arise. So the moment I started saying, I'm only going to hire students to work on this hospital project, just more people wanted to work with me because they thought I had a clear label about who I am and what I'm doing, so they could find me and reach out to me. Also, we found that by trying to solve these very specific problems, I have here the kind of a space rocket to remind me of NASA. So when NASA tried to go to the moon, send a man to the moon, they solved a number of problems that had spin-off applications. And we're finding exactly the same thing, that as we're trying to solve a very specific problem, there's huge potential to apply our solutions to different problems. So one example I want to mention is all this near-infrared scanning that we're doing. It turns out we can use 3D printers to manufacture barcodes that would have a unique chemical signature that you can then detect with a scanner, right? There's very interesting applications there. For example, we had people from the bank talking to us about adding those manufactured barcodes on bills, money. So you could have a unique signature on bills. So yes, I would advise you try and focus. Don't worry about it. You'll get more opportunities, and you'll have opportunities to do things outside what you're focusing as well. This is my last slide, and we have 5 minutes. Perfect. So I guess one thing I've come come across as people saying, well, if I work with medicine, I'll end up being a programmer for them, right? And there's that risk of becoming a programmer for other people. So what we've been lucky enough that we're actually not working with medical experts. We're working with administration in the hospital. So we're not working with the cancer doctor. We're working with their administration, and the work we're doing cuts across all these medical expertise. So actually, we did not end up being programmers for any big doctor. Hospitals are highly regulated, and regulations change between countries. It can be a limitation, like there might be legal issues that can hold you back or not. But if you manage to motivate your work with those regulations, it can be great. So hospitals have to demonstrate compliance with hand washing. That's why this is a great project, because of regulation. As I said, I had to get used to how the funding works in health. For example, I've been to a number of dinner bowls that they organize, these hospitals, and then people come and donate money, and I had to stand there and say, oh, give us money, we're going to solve important problems. We don't seem to do much of that in computer science. I don't know. But yeah, it's just a different way of doing things, I guess. I think this also offers a path to commercialization. So if you get funding and you do trials, it's a clear path then to do a spin-off company or startup. Some way to commercialize this technology. And what I have found is that small seed funding can be super crucial to enable this kind of work. So this work has been enabled by the small amounts of money that were available here and there for some equipment, for 1 or 2 PhD students. So you don't need big bucks to do exciting work, I think. You just need the right recipe and some seed funding. And the final question I get is, well, if you're solving other people's problems, who are you? What's your identity? So I consider myself to be a Ubicon person, right? So if I'm solving hospital problems, can I still be a Ubicon person? And I think the way to manage that is you just need to be very selective about which problems you solve. So in our interaction and visits to the hospital, they have a ton of ideas. And you spend a couple of days there and you have a dozen ideas about what to do. At that point, you need to be selective. And you need to have a nose or a smell for, what's the right way, which projects should I do here. So just wanted to conclude this. One day I sent my team up to the hospital. They were doing the indoor localization project, but then I told them, hey, the doctor called me and they said we can scan some samples for the IV project. So I got them in touch and I said, okay, did you guys get the samples? And then they sent me a picture. And they said, yeah, we got the samples. And we're doing the measurements, it's going well. And then I sent them a message to my students saying, okay, don't have too much fun with the drugs. And then I got this picture from, this is Gabriele, my PhD student. So we're having fun in the hospital. That's all from me. Thank you very much. Happy to take questions. Yes. So one day the hospital calls and says, hey, we're renovating the operating theaters. They're going to be offline for 3 months. Nothing you can do. So I told my student, okay, we've already collected a bit of data, spend these 3 months working on the software, the algorithms, and then we just have to wait. So these things happen, yeah.
How does your angle differ or relate to what people are doing medical folks?
Good question. How does it differ? Of course, I guess the answer is it depends, and depends who we're talking about. So one major difference is that if a hospital really wants to make this happen, right? These would be systems that need maintenance and support, and you need a kind of a company offering that. So that would be a service, and they do contract a number of services for that kind of person. So I guess one main difference is that we're clear from the start that we're building prototypes. That this will not be, we cannot give you something that can run for many years. If it turns out that we can solve this problem and it works well, we'll need to find a way to make that happen. So I think we're very clear that we're not competing. If you can buy something, go ahead and buy it. Don't let us do it. Yeah. The other thing I should say is that they're using a lot of systems, companies, but because we're talking with the admin, those folks are instructing those companies to give us their data. So they're using some kind of crowdsourcing application internally, for example, to allocate tasks to junior doctors. And they've given us access to this data and helping them understand why a lot of doctors commit suicide. Junior doctors commit suicide in Australia. So I don't think we're competing with companies, and if they are working in the hospital, we try to make the most of it. If we can get data from their technology, that's great.
Great, let's give us one more. Thank you.
Thank you.
Please come down and have a brief chat with us if you've got half time.
Sure. Or email me.